Today we will see about the refractive index of a particular medium. Refractive index of a particular medium is just a number. What does this number give you? It gives you a ratio of the speed of light in vacuum by the speed of light in the medium. Now, this is a very important concept. Here we write it as C naught and here we write it as C. C naught is 3.0 10 to the power of 8 meter per second. This is a universal constant that tells you that the refractive index of a medium varies inversely with the speed of light in a given medium. So from here we can say that mu m into Cm should remain a constant. This is of the form xy is supposed to be a constant, and if we would like to plot a graph between Cm and mu m, I think what we get is supposed to be a rectangular hyperbola. We'll learn something about what is called Snell's law. Snell's law tells you that the refractive index into sine theta should be a constant. This is just a number and this also is a number. But try to understand this is a variable number and this is supposed to be a constant. Back again we are able to get a relation that a number times a number is a constant. Again we need to get a rectangular hyperbola here. But what is all this? Let us try to see that this is supposed to be a denser medium whose refractive index is supposed to be mu, and here this is air whose refractive index is 1. Let there be a ray of light which tries to travel like this, and this makes an angle which is called theta 1 in the first medium, and the ray of light is going to bend because of refraction and it makes an angle here theta 2. For simplicity, let us try to call this as mu 2 and this as mu 1 whose value is 1. If we apply the Snell's law, remember that this is supposed to be the normal, this dotted line is a normal. And the same ray of light is making an angle theta 1 and theta 2 in the two media with the same normal. So as per the Snell's law, mu 1 into sine theta 1 should be mu 2 into sine theta 2. Here the value of mu 1 is 1 and this is called sine theta 1 and this is supposed to be mu 2 and this is supposed to be sine theta 2, which people call it as sin I by sin r. So mu 2 is sine theta 1 by sine theta 2. We call this as angle of incidence, we call this as angle of refraction. So we can also write this as sin I by sin r, which is supposed to be the refractive index of medium 2, which is nothing but the refractive index of the denser medium in comparison with the rarer medium. In this lecture, let us try to understand the meaning of TIR. TIR is total internal reflection. We are able to see that this is supposed to be a denser medium. This is supposed to be the normal. There is a ray of light which is going from the denser medium. Such a ray of light is supposed to undergo a refraction. So we call this angle as angle of refraction and this as the angle of incidence. If we are able to see that this is the direction in which the ray of light should have gone straight had there been a uniformity of the medium. But this is supposed to be the demarcating line which is separating the two media as far as the property is concerned, which means this is supposed to be the angle by which the ray of light has got deviated. So if we want to find out how much it got deviated, we can understand that this is the angle of refraction minus angle of incidence. So this is very clear. This total angle minus this angle gives you the angle of refraction. That's very, very clean and clear. Now, if I try to increase the angle of incidence here, the angle of incidence has been increased, this ray of light will graze the interface, which means the angle of refraction has become equal to 90 degrees. If we call this as the refractive index, then we can say this mu is supposed to be sine I upon sine R, but this is sine 90 and this is sine C, because what we call this big angle, we call it as critical angle. So from here we can say mu is equal to 1 upon sine C. So C is called the critical angle. It's exactly the angle of incidence in the denser medium whose corresponding angle of refraction is 90 degrees.